Hi everyone. Thank you for coming to this talk on increasing complexity in object play by developing beluga calves in managed care. I'm Malin Lilly, along with my co-authors Jackson Ham and Heather Hill. To provide a bit of background on belugas, they are native to Arctic waters. They live in a variety of social groups. Some of these groups include groups of just moms and calves. Sometimes they're of mixed age and sex, and sometimes they're just adult males. Beluga calves typically remain with their mothers for about 1 to 4 years and become sexually mature at about 7 to 11 years for females and 8 to 15 years for males. Belugas in the wild and in managed care have been documented interacting with objects. Some of these objects can include natural materials such as leaves or kelp, and also in both environments they have been seen interacting with man-made objects. What we know about belugas in managed care is that young belugas tend to play with objects more than adults, and object play tends to have longer bouts and more complex bouts than water and motor play. In belugas and other species, play can influence cognitive development. The young of many species play to test their limits, to learn about their world, to create those moderately discrepant events where they learn how things around them work. So for belugas, this can be things like how objects move and behave, what the beluga themselves can do to manipulate an object, how they can blow bubbles, what those bubbles can do, things of that nature. And so in this study, our goal was to look at the early years of belugas' lives and see how object play developed through those years. For this study, our subjects were 9 belugas housed at SeaWorld San Antonio from 2007 to 2019. Data was collected taking focal follow and scan sample videos of them. However, we did have a setback due to COVID. So the data set today includes 133 videos, which total 29 hours. However, we do have more that we need to add, but like I said, we did have some setbacks, and so there are a few gaps today that we can talk about. The videos that were taken are focusing on the belugas playing with objects. These were not taken during training sessions or when humans were interacting with them. So this is just the spontaneous behavior of the belugas choosing to initiate those interactions with the objects. So in terms of complexity, we wanted to assess complexity in a couple of different ways. And so the first was looking at how many behaviors were within a single object play bout. So while they were playing, did they do multiple things with the object, or sometimes maybe even other behaviors in between? So did they jump out of the water and toss the object in the air at the same time? That's 2 different things. And then we also wanted to look at what are these milestones when these behaviors are appearing across ontogeny or development? When do these new behaviors show up? And so I will go over how we looked at those 2 different aspects of complexity. So this is looking at the number of behaviors per bout, and month of life is on the x-axis. This is looking up to 36 months of life or 3 years of life, and then how many behaviors were within each bout. And so interestingly, there is no linear correlation across life, a month of life, for the number of behaviors. The variation is about the same in the early years up until the 3 years of age. And so, like I said, we are missing some data points that we hope to fill in here. And so hopefully we'll see if this trend of no linear correlation is still there, or if it might change slightly. We also wanted to say, okay, well, is this just in the first 3 years? So we zoomed out a bit and looked across the first 5 years, and this trend where equal variation across all these months is still continuing. And so that was surprising to us. And we'd like to talk more about measuring complexity in our discussion. So another way we wanted to assess complexity was to look at milestones and when certain behaviors appeared across ontogeny. And so we recorded the first time a specific behavior was observed. So the first time an individual pushed an object, the first time an individual took the object in its mouth and swam around with it in its mouth. But then we picked specific milestones that we thought were particularly complex. So in the first series of images, this is an individual putting this ball up on a ledge, and then in most cases, the individual will retrieve the ball off the ledge. And so in this way, they're making the situation a bit harder for themselves, putting the object sometimes completely out of reach, but usually just slightly out of reach. And so this is what we thought a particularly complex behavior. And the behavior on the bottom is this individual actually beaching themselves slightly to retrieve this object, and they can retrieve an object in a number of ways. So they could swim by and create a wave. They could swim up and then push the object off with their head. In this case, the individual is actually pushing the object into the wall more and then kind of flicking it up in the air so that it actually bounces off the wall, comes out in the air, and then they're able to then do whatever they want with that object. And so I'm going to show you a number of different behaviors that we noted as milestones for all of the individuals in our study. So this is what month this was first observed. And so I just showed you the beaching to retrieve the object, the first month that this was observed for each of the individuals, and then on average, this was observed at 23 months. Another milestone was if they're interacting with two objects, and this was first observed at 23 months on average. If they're doing two actions with one object, so maybe they are jumping out of the water and they're also tossing the ball in the air at the same time. Belugas are known to spit water at objects in their environment. In this way, they're actually creating a mechanism to move the object without actually touching the object themselves. The average time that this was first observed was 28 months. This is also true for bubbles. Bubbles can be produced and then the bubbles can then move the object. And so this was first observed on average at 20 months of age. And then lastly, a milestone that we thought was particularly complex was when the individual puts the object on their flukes. And so their flukes are their tail, and they can actually pick up the object with their tail, but their tail is actually used to move them around and push them forward through the water. And so it's a little bit more complicated to be able to pick up objects, manipulate objects, toss objects up into the air using the flukes. The average time this was observed was 22 months of age. And so averaging all of these milestones I just talked about together, the average of these milestones is 24 months of age. And then we also wanted to look at not just these actions that we thought were particularly complex, but again, the first time the individual touched the object with their head, the first time they touched the object with their side, the first time they bit the object and carried it around. So the average of all of those behaviors and the first time they were observed was 26 months of age. So here on average, between 2 and 3 years of age is when most of these behaviors are observed, really 20 to 30 months of age. And that seems to be the average for when new behaviors in general emerge. And so that's very interesting. You can see a number of different individuals where they may have just never done that behavior or have been observed doing that behavior, or this is part of our COVID-related data issues where we need to still fill in the gaps. And I had said previously that we're currently working on that. So we hopefully will have that soon. However, that's the general pattern. It is also interesting to look at this individual variation. So the 3 individuals who are highlighted now on the screen did engage in a lot of these behaviors much earlier than their counterparts. And so the question then is, where is this individual variation coming from? It could be coming from differences in behaviors they've observed their mother do because they're individuals as well. It could also be differences in access to peers. Belugas from previous research have been documented to interact mostly aside from their mother, with similar aged peers or slightly older peers, so juvenile. And it could be that some individuals had more opportunities to observe these different behaviors in others as well. And so that's something that we want to look into further. It's possible this individual variation is what's really driving that lack of pattern for behaviors appearing across all belugas, because there's so much individual variation going on here. So that's something to look into in the future as well. Again, this is just object play, but they also engage in motor play. Sometimes there's a social component to the play as well. And so a lot more specifics need to be looked into there. So overall, we did not see a linear trend in the number of behaviors per play bout. We thought that they would increase over time, but they did not. Then looking at what new behaviors appear across ontogeny, most of these behaviors were appearing between 20 and 30 months. And so this lines up with previous research on belugas really needing to learn to become independent, because they only stay with their mother for the first few years of life before they do need to be able to be on their own. And so this is the time that they would be learning all those things about their environment, how to manipulate objects, what things in their environment do. However, there was no clear pattern in specific complex behaviors emerging much sooner or later compared to other behaviors. And so a lot more work needs to go into this. So for the future, and a topic that I want to bring up maybe for discussion today, is how we can best measure or assess complexity. So maybe you listening to this presentation have some ideas on how we might be able to assess complexity, and very early on here in development. And if you have any thoughts on that, I would be happy to discuss them. With that, I'd like to thank the research assistants who helped with this project, SeaWorld San Antonio, and you for taking the time to attend this presentation. And if you have any questions or would like to discuss further, I'd be happy to do so. Thank you.